And today we're going to be going over NX CAM and the IPW in Process Workpiece. So what's on the agenda? What is the IPW, the in-process workpiece? What does this do within programming? IPW options, and then carrying the IPW downstream to subsequent operations or subsequent setups. And then the flow of the IPW from start to finish. So what is the IPW? IPW is in-process workpiece. So what NX does is every time it removes material from the stock, it does a volume comparison between finished part and stock. And that's why NX is stock aware. It doesn't create air passes. It will cut only material. So that's one unique thing with NX that other CAM systems don't have. All of the CAM systems, you have to finagle your operations to cut as least amount of air as possible. There is no true material aware software that I'm familiar with other than NX. So now we're going to take a look at the in-process workpiece and some of the options that are available to you in the in-process workpiece. And then once I get into the demo, I'm going to explain to you what I see in industry all the time. Even from super users, I still see them using the software the way that they were taught in NX4, NX5, where in-process workpiece wasn't necessarily as big of a deal as it is now. So you can really make your job a lot harder if you don't know the proper flow of the IPW and how to utilize it correctly. I see people that they run the verification and then they save an IPW out of that to carry on subsequent operations or within the same program. Within the same program, completely unnecessary. NX knows exactly what's there. Going from operation 1 to operation 2, there is a lot of things that can go wrong with carrying an IPW in that fashion into the second operation. One being that when NX produces an in-process workpiece in that fashion, it's a faceted model. So there's a gazillion triangles that create those surfaces. So if you had an intricate surface that you're trying to 3D machine, it's not going to be what you expect it to be. So there's several reasons why you wouldn't want to go that route, but I see it heavily in industry still. Now, some of the in-process workpiece options we have in the ribbon in the center there, you'll see display IPW. You can hit that at any time and see the current condition at the operation you've selected. If no operations are selected, it'll go through all the operations and it will give you an in-process workpiece. In the Show 3D IPW dialog dropdown, there are several different options. Show 3D IPW is just going to show the original condition of the in-process workpiece. For lathe work, it'll show the 3D spinning IPW. The Analyze, it'll allow you to go in there and actually measure stock and what you have left. It'll give you color coordination. And if you click on the model, it'll show you, just like in verification, it'll show you exactly how much material you have left. Now, the Save IPW As, that's the option that you have to actually create a component, but that is going to be a faceted model. There are some applications to where that could come in handy, but I have not found a reason yet to where I've had to create a faceted IPW. Now, if you choose delete 3D IPWs, what that's going to do is it's going to delete the current condition in the background. And then once you hit display IPW, it will regenerate that. And the only time you really would need to do that is when you have several operations, several workpieces inside of one program, and NX loses the path between one and the other. So it's not displaying the correct IPW. You can delete them and then reselect them, or regenerate them. Select 2D IPWs is for a lathe type of cross section. And then you have an IPW resolution down at the bottom. Now just make sure that you understand that if you switch that to fine, it's going to process much slower. Put it on coarse, it's going to process faster, but the screen is going to be coarse or fine comparison. So depending on what you're doing and what you need to visualize, you may want to adjust that. So now let's get into a demo of in-process workpiece. So I'm using NX 1915. That's the latest release. And I have a part here. So this is the shaded transparent piece, the stock. The yellow piece is my actual part. So, excuse me. And one thing I want to show you right from the very beginning is how in-process workpiece can be used. So in your specify blank, if this were the second operation to where I already had previous in workpiece in operation, you just select the IPW. You check the source for IPW, and then you browse out to that original file and you select the part. Once I select this, it's going to give me my workpieces. This particular one, it's not set up to do that, so I'll do an actual demonstration later. But when you do this, it will automatically bring in that 3D IPW, and it will show you an exact representation of what you're working with. It's fully associative, so if your original operation one gets changed, it will perpetuate downstream, and it will modify the IPW. But because of the associativity factor, all you have to do is regenerate. So what this alleviates is, most of us know that when we do large programs inside of one program, if you start moving operations around, it will conflict with other operations, and then toolpath from way up top that's not changed will go out of date because it affects them. Doing it this way, it does not affect other operations, and you can move things around without affecting the first operation or downstream operations. So what I want to do first is I want to show 3D IPW. So after I'm on this workpiece level. So this is what's the in-process workpiece after I have these 3 operations done. So that's what the Show 3D IPW button does. If I do Analyze, I get a color coordination. I have a scale here, and I can click on the part, and it will show me the actual stock. This is the exact same analysis dialog that is in the measurement commands, the analysis tab. It's the same exact thing. It's the same exact one that you can pull out of visualization. It's just it's the same exact tool, except it's utilized in different modules. This one happens to be IPW. So now, what does IPW do, and why is it beneficial for us in programming? So I'm going to take these operations, put them in the unused items so they're not being analyzed. When I go and I utilize the IPW, this is the first operation, so it's just going to cut what it's able to cut. I don't have any geometry selected, so it's going to be all-encompassing. And for those that don't know, cavity milling, rest milling, they're all very volume-aware operations. So you don't have to select a cut area, but it's going to do the entire part what it can do. If you want to segregate certain areas, then you just select the geometry that you want to cut. And with that, you say specify cut area, then you select something, and it'll contain it to that area. So now that I have this operation done, I can go up here and I can hit display IPW. The only thing that's different between Show 3D IPW and display IPW is Show 3D IPW will be the operations I have selected. Display IPW is for current condition, no matter what selection you have. So you can see I'm sorry, let me finish this. Okay, so if I go here and I hit Show 3D IPW, this is the condition after that operation. Now, what NX does is it analyzes this before every cut. So if I go and I pull in my first rest milling operation, I told it that I only want to cut this face at a vector normal to its surface. Once again, no geometry selection. Now, when I generate this, any other CAM system out there is going to look at this corner because it's the stock condition. It's going to start at that level, and then you're going to have to finagle your negative approaches or negative stocks to be able to cut only material. With NX, you don't have to do that. It's only going to give you a cut that is cutting material. So now, just to show you what I mean, if I take this rest milling and put it up here, program order view. Now, if I generate this, it looks at that IPW and it says there's stock there. So now it accommodated the stock that was out here in the corner. Once I put this cavity milling back in place, it resets the IPW. I regenerate the rest milling, and it gives me a path that's indicative of no stock. So that's how NX is volume aware. Now, if I go and I pull in this other rest milling, this one. So now when I cut this, it was straight down in Z. So it looked at that and it said, okay, this material on the side here, it's gone at that top level here. It sees that that stock is gone from the sidewall to that surface. So that's where it starts at. Its first cut is at the below the surface. So that's how it is stock aware, and that's the efficiencies of NX. So that particular instance is just showing you how NX is volume aware, stock aware. Now, if I hit display IPW, it's showing me the IPW condition from here. So now if I display IPW, it's showing me nothing's been done. If I go down here, that's the difference between the buttons. Display IPW is only active on the actual node you're at. Now, if I go back here and I say show 3D IPW, it'll analyze all operations and it will give you the current condition. And these become very helpful tools, indicating tools that what needs done. So if I'm programming and if I'm down to semi-finished stock condition, I always go to analyze, and it shows me with color coordination exactly what needs done. And not only what needs done, but I can say, well, this isn't finished, but how much is it not finished by? 1 inch, 130. So it's a very useful tool. So now, other things with IPW is, I'm going to show you inside of this program just for simplicity. If I took this program, no, I'm sorry, let me open up another one. I already created this for you. So now if this becomes my secondary part, I do the same as I did in my first. This is my finished part, so that's my stock, or that's my part. But now my blank, instead of choosing any other option or saving out in IPW and bringing it back in as an assembly component, we just select source for IPW. You go browse, IPW, our original part, and then it gives you your operations and your workpiece. It only allows you to select the workpiece level because it incorporates all of its operations. Once I hit OK, I hit update local IPW from source. It pulls in all of that information from the original program. So once I hit OK to this, I'm just creating another cavity milling operation. But what you're going to see is it's only going to cut material. It's not going to cut anything else. So that's a perfect definition of stock awareness. But also, what happens if I go here and I say, that's the only thing cut is this cavity mill. Now I go to my second. Everything is changed. All I do is I hit update source. I go into this. The cut levels, they don't necessarily always update. So you go into your cut levels and make sure that it's automatic. And then it will give me a full toolpath for what material is there. So you see the associative factor between operations. So now if I start messing around in Op2, it's never going to change Op1. Now, if I had Op1 and Op2 in the same part file, which I see a lot in industry, which is not the right way to go, The best way to think about when do I program multiple files is if that part ever comes off of the machine, a new program is loaded, and new fixturing, a new setup, or as minimal as a new program is loaded. That's a new file. That's not inside the same file. If you have 6 sides to a part, you should not have workpiece operations, workpiece operations, workpiece operations. What that does to you is it confines you into one program. You still get the same associativity factor, but you have to be selective and careful on what you're posting, what you're not posting, program folders for organization. But what it does do is when you get downstream 4 or 5 operations, you're going to start losing your connectivity between inside of one file and how it operates to how it looks at all this data between files. Because NX is very intuitive. It will say, this is my first operation. It will put certain strategies in place for second operations, different strategies for third. So if you have it all in one operation, NX, or one program file, NX sees this as one push button start, and then it finishes that program. And you can tell it to do side 1 program folder, side 2 program folder, but that's just not the correct best practices of NX. So how would you do it in that way, or how do you flow the program correctly? So now I do not have a second operation. I'm going to put these back in place. Regenerate. I'll have my file called back up. And this is the best practice flow of how you should be creating manufacturing files within NX. So once this generates, you save it, file, new. This is the procedure for every manufacturing file, side op 1, 2, 3, 4, 5, whatever it may be. You always open up your CAD data, whether it's in gateway, modeling, whatever it's in, file, new, manufacturing, choose your template. What these templates do is they set up your environment. So if I choose general, it's going to give me every available option in it. If I choose turning, it's going to set up a MCS, a workpiece, a turning workpiece, and an avoidance. So it will give you the correct NX environment for whatever option you're trying to do. Just know that general has all of them in it. Everything looks good here. And what this does for you, if you go directly, I chose the wrong one, sorry. What it does is it takes your singular component file and it puts it into an assembly. And if you do not do that, you lose wave geometry linking ability. You have to manually set up your assembly file. This does all this for you. So anyway, what I'm going to do is open up another part and show you what that. For those of you who do not know where these are located, NX has several sample parts that you can use and utilize for whatever. They have operations in them that you can test with. And those are anything that's relating to manufacturing is in the mock folder. Samples. So there's a lot of there's a lot of samples, and there's some tutorials here too as well. So we'll just find something that's fine. So this is opened in modeling. Now you just file, new, manufacturing template. So now when I open this, it's going to be in an assembly environment. My part is on screen. Now I need to do a couple things. I'll give it an actual real MCS. I'm just going to set this anywhere. Indicative of 3-axis, of course. Looks good to me. So now what I'm going to do is set a workpiece. Set my blank. I'll just give it a bounding block. So now I'm ready to start programming. I'm just going to throw a couple operations in it, cavity milling operations. I never choose a tool and I never build tools from the start. I always go to the library, pick something, modify it, save it back to the library. That's just my method. It's much simpler for me, but I know people who sit there and strategize and create all that tooling up front. I just don't see the point in it. Now I'll do a drilling operation. Here's where the analysis comes in nice. (9.5), that's a 19 millimeter with a 13 millimeter hole. So my tool probably will be able to do that. And it's a 10 millimeter. So we'll just go in. I'm going to create another tool or create another operation. This time we'll do hole milling. Hole making. We'll do circle milling. And then I'll just get an 8 millimeter tool. Now it's asking me for my features. And if I was programming this realistically, I would create a group with those features in it. So I only have one selection. And I covered this in hole making last time. That you see how you have entities, machining area entities. I have the top cylinder, I have the lower cylinder. So all the entities are there. Here is all the parameters of those entities. So that's the top. Remember, pasting inside is the one you want. I simply change the drop down to 2. It already selected 2 because it sees the in-process workpiece has already done this. Now, if I'd keep this at 1, this will give you the explanation of depth, or IPW, I'm sorry. So if I try to process this, it'll tell me I have I use a smaller, I know, I'm sorry. If it was done, it would tell you, if you get a message down here that says the feature's already been fully machined. I just got it. Feature already completely machined by previous operation, show geometry. So it's telling me that this top section has already been finished, or the bottom section. Which one is done? Top section. So if I put cylinder 1 back in there, I'm going to choose cylinder 2. I'm just going to OK this because I must have it wrong in this one. So this needs to be cylinder 1. Generate. And this one is cylinder 2. So now if I verify this, it's showing that my shank is rubbing. So this is doing the verification. Now, once this is finished, I'll show you where the options are to create that faceted IPW. Just remember that this is not an IPW. This is more of a, if it's 2.5D prismatic machining, yes, you can do it on the faceted model. If it's any type of surfacing, you cannot do it on the model. So that's the condition that I have. So now what I do is I save this out. File, new, manufacturing template, general setup. I have to do the same. Give it a decent work 0. Now when I go into Workpiece, my part is always going to be my part. My blank now becomes IPW. Select the source. It was this part here that was always used. I want to update that source. It's going to give me the correct IPW from the operation 1. Now I need to reverse that MCS. Now I'll do the same thing I did before. I'm just going to grab a tool. Nothing has been selected on the part. It goes volume to volume, and it cuts away stock part. Now, once this is finished, this is the only way to do the IPW, to save the IPW through verification. You have to let it run. Then you go to this IPW, you save, which saves it into this part file, or you save as a component, which will save it to a folder, and then you can bring it in manually. If you don't save as component, then it's not independent. It's only in this file, and it can't be looked at by any other file. So if you do hit save, or you can hit create, and what create will do is it's going to just create the IPW in that condition, and it gives you the analysis tools like you did before. So that's the process of saving out the IPW from an operation. But again, I do not recommend this. So now that's how you move operations from one to the other. Operation 1 to operation 2, you transfer the IPW from 1 to 2. Now, what do you do if you have to say this is a highly intricate curved surface that I'm not needing to 3D mill? There's another facet of how this works. That's the wave geometry linking. We have to do this a lot because if this is hands down all CAM systems as well. There's little utilities that make things nice in other systems. NX has those utilities as well to put patches over top of holes or grooves, or because the tool, if it can go into that area, it will try to go into it. And when you're running 75 inches a minute, you don't want any interaction of different axis or letting your ball screws reverse. You'll see it on the part every time. Even on brand new machines, the backlash is just, it's always there. So what do we do if we have to do this? This will not work if you go open up your model and go application manufacturer. It absolutely will not work. The options are not even available to you. The reasoning being is this part is our design data. This is the design intent that the designers want made. They don't care how we make it. It just has to be this. So we would never alter this because we're altering the biblical data that we were given. So the way that we can do this is we would go assemblies, excuse me, wave geometry link, body. You have different options. I'm going to choose the whole body. Doesn't look like it did anything, but what it did is it created a linked body here. This is associative to the original. So if he changes his in design, it will automatically perpetuate to my geometry linked body. But now what we can do with the geometry linked body is we can use our synchronous. So now if we're using that as our first part, we just select that as our first part. Our stock will still be the same. We'll run our cavity mill, which will remain the same. But if that was a curved surface, then it would not try to go into the holes. But now how do we catch up? How do we finish? You always have to finish your part on the design data, the designer's design data. So how do we do that? Create geometry, workpiece, when I hit OK to this, it's in the same level. That's why it was grayed out. We have to bring this back up to the same level. If we don't need a MCS, it'll go off of the first one, just like the tree always goes. But in this workpiece, we say that this is not our part. This is our part. We hide our length body. This is our finished part. Our stock now is the first workpiece. We update it. And I'm sure that the guys out there on this call that utilize IPW, saving it, bringing it back in any fashion, can completely see that this is the most efficient way to go about in-process workpieces and stock control. This is so much simpler than all of the other options available to us. So now we can do anything we want on this workpiece. I'll just circle mill out those holes real fast. So the first one always thinks a little bit harder than the rest of them because it's putting all of its all the data there. But once you have it, then it just copies that data to different location points. Excuse me. So you see exactly how this all works. It 100% of the time it looks at the, so it's on the wrong side of the part. How do we fix that? Reverse direction. Okay, there's the whole milling, now our workpiece. That was supposed to be in this one. So that you can see how this carries throughout. Now if I want to see the in-process workpiece, I don't have anything selected, so they're grayed. So that's the way in-process works. That's the options to in-process workpiece, and that's the best practice of how NX would like the data given to it so that it can analyze and keep track of it downstream. So if you are one of the guys that program a full part in one part file, there's many reasons why people say they do that. One is organization, don't have as many files. There is a rebuttal for everything that you have already learned that I try to show something different. And I understand that it's the way you learned and that's what's more comfortable to you. But if you really try to implement this methodology, you'll see that you've been doing it the difficult way for a long time. So if you have any questions, feel free to reach out to me on how this works. As Andrea said, the YouTube video will be available shortly, but I'm always available to answer questions. So 3 takeaways from today's session: the importance of IPW, utilizing it through the single program, and then how to use the IPW downstream for multiple setups. Carrying the IPW now when I wrote this, how to use the IPW downstream, that IPW that's driven out of manufacturing can be used in any module of NX. So if you have to model something, a fixture or a secondary part, an attachment, you can directly drive that design off of that IPW. Carrying in IPW to subsequent setups, that's within manufacturing, and that is where you have setup 1, setup 2, setup 3. A lot of people don't like the automatic nomenclature. Me personally, I would much rather see model name _ setup, whatever setup I want. So I just leave it standard right out of the box. and that'll give you a good indication just by looking at it, what part it is and what operation you're on.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.